Competitive Triple B everyone. Good evening everyone. Welcome to the Competitive Triple B. So today I'm going to discuss about the 10th class NCERT topic metals and non-metals. So here, first of all, when it comes to the metals and non-metals, how it will be useful to us. So here mainly whatever the things we are using nowadays, like for correct utensils like this, it will be connected to our daily life. So when it comes to this, so metals and non-metals is a major important chapter. It is going to having the keep on having the connection with our daily life. So that's why. So move on to the concept explanation. So let us start with the metals and non-metals topic. So in that, first of all, so what is meant by metals? Let us start with the metals and non-metal. So here first comes to the metal. What is meant by metal? So when it comes to the metals, so elements which are having the valency of 1, 2, 3, those will be known as a metals. So metals are generally having the 1, 2, 3 valency, and then these will be known as a metals. So metals are, we are saying as a 1, 2, 3 valency containing elements are metals. How? So why? Because so here generally whatever may be the element, if they having in the outermost shell 8 electrons, that will be called as a stable. So but we are saying 1, 2, 3 electrons, means these were the excess electrons. When it comes to these will be considered as a excess electrons. So when these excess electrons were there, automatically element will be considered as a unstable atom. So then when it comes to the stability, how it will be? So by using these 1, 2, 3 electrons, elements will be converted to the cations. In that format, elements get the stability. Then the capacity of the element which is having lose the electron as 1, 2, 3, those will be known as a metals. So here when it comes to the occurrence, so generally we have the most abundant metal will be aluminum, then iron, calcium, sodium, potassium, and the last magnesium will be. So then, so these will be considered as the order of the availability of metals. Okay. Next we have the non-metals. When it comes to the non-metals, these are quite opposite. So here they having 4. So generally wherever 4 is there, preferably those will involve in the covalent bond formation. So that's why we can't consider. But when it comes to the non-metals, these will also part of the non-metals. So mostly the elements which are having the valence electrons of 5, 6, 7, those will be known as a non-metals. So here non-metals means here 5, 6, 7 we are saying. What is the stable configuration? When element is having 8 electrons, that will be the stable configuration. But here we have deficiency of electrons. So the elements which are ready to accept the electron and form as anions, those will be known as a non-metals. In that aspect, if you see the occurrence, most abundant non-metal is the oxygen. Most abundant non-metal is oxygen, 50%, and then we have the silicon. But most abundant non-metal which is available in the atmosphere means in the form of gaseous state, means we used to say nitrogen. Okay. So now we will go for the next slide. So order if you see, oxygen, silica, phosphorus and sulfur. This is the availability. And in the atmosphere, if you see, most abundant non-metal is the nitrogen. So now we will go for the next one. Physical properties of metals and non-metals. When it comes to the physical properties of metals, how can we distinguish metals and non-metals? So when it comes to the metals, we used to say that generally these are in the solid form. So these will be exist in the solid form. But here exception is there. Mercury. In thermometers we will use, this will be in the liquid state. Welcome to the channel. Happy good evening. And here if we see metals are generally exist in the solid state. Here we have the exceptions regarding the mercury and gallium. So mercury exists in the liquid state. And when it comes to the non-metals, these will exist in all the three states. And next, when it comes to the metals, generally heavy means they having the high density. But when it comes to the potassium, sodium, magnesium, these are having the less density. So these are lighter in weight. When it comes to the non-metals, we used to say these are having the less weight. So next, when it comes to the metals, these are hard and non-brittle in nature. What is the meaning of non-brittle? Can't be able to break down. Cannot be break down easily. So here, when it comes to the sodium, potassium, lead, these are the soft metals. We can able to cut them by using the knife. By using the knife, we can cut them. Solids are the non-metals. These are hard in nature and brittle in nature. So here we can able to break them. And next, when it comes to the metals, these are the good conductors of heat and electricity. Why? Here exceptional property is there. We have to focus on those only. Based on those, these only we will get the MCQs. So here generally lead will be considered as a good conductor of electricity. And next, when it comes to the bad conductors, the non-metals will be considered as a bad conductors. So here one exceptional property is there, that is a graphite. So it is a carbon allotrope which is having the free mobile electrons. So due to these free mobile electrons, graphite will shows the conductivity property. Pencil lead is made up of graphite, so it will be showing the conductivity property. And when it comes to the metals, we used to say ductile and malleable. Generally, metals are ductile and malleable. But when it comes to the non-metals, this will be neither ductile nor malleable. Means this property can't be shown by the non-metals. So here boiling points, generally melting and boiling points are very high. When it comes to the non-metals, these are having the very low melting points. And when it comes to this, generally corrosion and this ringing sound and collisions, this will be called as what property? It is called as a, the property will be considered as a sonorous. And not producing ringing sound, it is a non-sonorous. Ringing sound usually we will hear with the metals. So that will be known as that ringing sound. Collisions, whenever we are making collisions between the two metals, it is going to keep on give the ringing sound. That will be known as a sonorous property. When it comes to the non-metals, these are non-sonorous in nature. So when it comes to the metals, these are lustrous in nature. So that's why we are making ornaments and everything that will be very shiny in nature. So next, when it comes to the non-metals, these will be considered as a non-lustrous. Can't be polished. So we will go for the next slide. So here, few examples were given in the tabular form. Lustrous is nothing but metallic shine. So generally all metals are lustrous in nature. So lead is the exception here. When it comes to the non-lustrous, here iodine and graphite are the exception. Both are having the lustrous nature. When it comes to the hardness, generally all are very hard in nature, but sodium and potassium, these will be easily cutted with a knife. So that's why these are the exceptions. When it comes to the non-metals, generally these are very soft in nature, but when it comes to diamond, it is hardest substance. We can't able to cut them. So by using another diamond, we can able to cut it. So malleability property. What is the meaning of malleability property? Is beaten into the thin sheets. So we can make them into the sheet form. Those will be known as a malleability. Highest malleable substances are gold. Highest malleable substance is gold. That's why we are using in the ornaments making. So here exceptions are zinc, antimony and arsenic. So generally when it comes to the non-metals, these are non-malleable substances. And when it comes to the ductility property, drawn into wires, copper, white. So here best example gold and copper we can take. When it comes to the ductility property, here also once again exceptions are zinc, arsenic and antimony. When it comes to the non-metals, those are non-ductile in nature, but here carbon can make it into the fiber. So this is an exception. So next, conductivity property, generally these will be good conductors of heat and electricity. Here exception is for bismuth and tungsten. So when it comes to the non-metals, these are the bad conductors of heat and electricity. Here exception is graphite as a gas carbon. States, generally metals will exist in only in solid state, and when it comes to the non-metal, these will exist in all the three states. Density of the metals are high. So when it comes to the first year group elements, these are having the exception, that is potassium and sodium. These will be having the less density. And when it comes to the non-metals, generally these are having the low density. Here exception is about diamond. So it is having the highest density. So now we will go for the chemical properties of metals and non-metals. So here when it comes to the metals and non-metals, this is a very important concept. So when metals are going to react with the oxygen, means metals reaction with oxygen is nothing but burned in the air. So whenever metals burned in the air, we used to get metallic oxides. So metallic oxides when dissolved in water gives the respective bases. So in that aspect we used to say metals are metal oxides or metal hydroxides. Metal hydroxides all will be considered as a bases only. All will be considered as bases. So when it comes to the non-metals, when burned in the air gives the non-metallic oxides, when dissolved in water gives the respective acids. So we can say that non-metals are non-metallic oxides are non-metal hydroxides. All these will comes under acids. Means acidic in nature. Here we will say basic in nature. How can we prove it? This is a question. So by using the litmus test. So in non-metallic oxides, blue litmus turns to red. Blue to red we can able to see. So but when it comes to the metallic oxides, red litmus turns to blue. So from that we can conclude that metallic oxides are basic in nature and non-metallic oxides are acidic in nature. So now we will go for the next slide. So corrosion topic. So when it comes to the corrosion, so here generally iron when exposed to the air. So here plenty of moisture and oxygen are the required substances. So when moisture and oxygen is present more in quantity, then automatically iron will be corroded. The corrosive product will be called as a ferric oxide. So here we are writing Xmos is nothing but here how much moisture is available in the atmosphere, that is totally captured by the iron to convert into the ferric oxide. So that's why we are writing X. So then the color of the rusted iron is reddish brown color. We usually see at home also. Next, when it comes to the aluminium, it requires only moist air, then it will be converted into the aluminium oxide, which will give the dull appearance, pale color. So next we have the copper. So when it comes to the copper, it will be required conditions. It required condition is moisture and carbon dioxide and air. So means in that moisture, oxygen and carbon dioxide are the available conditions. In that case, the formed substance will be called as a basic copper carbonate. basic copper carbonate, which is greenish yellow color. So that's why to remove this corrosive product, we will use the lemon juice. So whenever we are using lemon juice or tamarindus juice, this basic copper carbonate layer will be neutralized, and then this coating will be removed and copper vessels will become shiny. So next, when it comes to the silver, required substances are air and silver sulfate. But when it comes to the silver, generally we used to say that this is a least reactive metal. So that's why directly it won't give the silver sulfide as a corrosive product. So here, first of all, what will happen in case of silver is, it is a least reactive metal. That's why it is going to react with oxygen to give the silver oxide. And then this silver oxide is going to react with the hydrogen sulfide to give the silver sulfide. So which is a black color substance. So silver ornaments, whenever we are wearing continuously, if we wear after few days, those will be turned back. That will be known as a corrosive product because of silver sulfide formation. Okay, so now we will go for the reaction and reactivity of metals. So how can we prove that these are the metals are highly reactive? So regarding this, if we see, Preeti, are you leaving from the class? So now, when it comes to the reaction with the water, first reaction, so when it comes to the sodium, potassium, calcium, aluminum, up to here. These metals can react with the cold water. Resultant reaction, byproducts are these only. So then reaction will be vigorous, very violent. So when it comes to the magnesium, see here, magnesium reacts with only hot water to form magnesium hydroxide. So here, less. When it comes to the calcium, compared to sodium and potassium, it is least reactive. That's why here, less violent. Reaction will be taking place, and with the cold water only, it is giving calcium hydroxide, but it is a less vigorous reaction. So now, when it comes to the metals like aluminium, iron and zinc, these are going to react with only steam to give the metal oxides and hydrogen. So here, aluminum oxide layer is forming in these two cases. Earlier we got the magnesium respective hydroxides, but when it comes to the aluminium, iron, zinc, these are amphoteric in nature and these are giving the oxide forms along with the hydrogen gas. So here, one more thing is that when it comes to the sodium, potassium, with the cold water giving a violent reaction and catches fire, we are saying. So that's why to prevent all these actions, we supposed to store sodium and potassium in the kerosene oil. So here, these are highly reactive metals and reaction is very vigorous when come in contact with the water and oxygen. To avoid that, we have to store them in the kerosene. So next, when it comes to the calcium, it is less violent. But what will be the observation is, so whenever hydrogen gas is released out, so because of hydrogen gas bubbles, calcium and next we have the magnesium. So these will be floats upon the surface. Okay, you have to remember this. Based on this, we used to see the question. And when it comes to the aluminium, iron and zinc, these are the least reactive metals compared to magnesium, calcium, sodium, potassium. And these will be reacts only with the steam to give the respective metal oxides. These are the amphoteric oxides. So metals like lead, copper, silver, gold don't react with the water. So that's why this gold and silver will be used to make jewelry. So why we are using them to make the jewelries is because of first property is lustrous nature for every metal we have. So first property is malleability. First property is malleability, And second property we can take as a lustrous and non-corrosive in nature when come to contact with the water. So in that aspect, this will be used in the ornaments. So lead is a poor conductor, so that's why we will use that for the soldering purpose. Why? Because this is having the low ignition point in the formation, in the format of alloys. So next, so here this is a high reactivity series. So when it comes to potassium to calcium, these will react with the cold water, and when it comes to the magnesium, reacts with the hot water, and these will react with the steel, and these are the least reactive with it. That's why it doesn't react with the water. Okay, so now we will go for the next thing. So reaction with the acids. When it comes to the reaction with the acids, here if you see hydrochloric acid, if we take, commonly every time the compound formed will be respective salt. So here generalized equation we will take. So metal plus HCl gives rise to salt plus hydrogen gas. Okay, this is a common thing. So whatever may be the condition, we are getting always hydrogen gas. So how can we identify hydrogen gas is for released out? By using the burning splinter. So it gives the pop-ups. This is an identification test for the hydrogen gas. But here one exception is that when it comes to the copper, in the dilute or concentrated condition, no reaction will be takes place. In hot concentrated condition, copper chloride is formed. Okay, so this is an exception. So that's why we have to focus on the copper abnormal properties. So copper only in the hot concentrated condition of hydrochloric acid only gives the hydrogen gas. Other than that, in remaining all conditions, no reaction. So for silver and gold, whatever may be the condition of the acid, so no reaction taking place. Okay, so we will go for the sulfuric acid. When it comes to the sulfuric acid, here we are getting the sulfur dioxide as a common product. Why we are getting the sulfur dioxide? So here we usually say as sulfuric acid is a strong oxidizing agent. Strong oxidizing agent. Therefore, itself reduces to respective, due to that reduces to respective sulfur oxides. And instead of hydrogen gives water molecule. So as usual, common product. In case of dilute condition, no reaction. Hot dilute condition, we are getting the sulfur dioxide and water. When it comes to the silver and gold, no reaction taking place. So now we will go for the next slide. When it comes to the nitric acid, it is very, very important, repeated question. So when it comes to the potassium, calcium, whatever may be, sodium, potassium, calcium, if we take very dilute and dilute condition, we are getting the NO product. Okay. So, but when it comes to the concentrated or hot concentrated condition, this you supposed to highlight. Concentrated, hot concentrated condition, we are getting the nitrogen dioxide. So here, in the concentrated, hot concentrated conditions, we will get nitrogen dioxide. So in remaining all conditions, we will get the nitrogen oxide. And one more thing, here when it comes to the iron, aluminium is giving respective oxides. Then passive, the reaction is passive and oxide layer is forming. So this will be the total differently given products. So this is supposed to be remembered. And next, copper. It is very, very important one. Abnormal properties of carbon expected questions. So in the very dilute condition, no reaction is taking place, and moderate concentration we will get NO, and in the concentrated or hot concentrated condition we are getting the nitrogen dioxide. This also you have to remember. So when it comes to the silver and gold, whatever may be the condition, no reaction. And one more thing here, we have one more exception. When it comes to the magnesium, manganese and zinc, here these are going to liberate hydrogen gas. These are going to liberate hydrogen gas. In the moderate and concentrated or hot concentrated condition, they are not going to liberate the hydrogen gas remaining elements, but they giving NO or NO. So why? What is the reason? Is strong oxidizing agent. Earlier I told you. So gas will be converted into water. So these two also you have to focus. Magnesium and manganese are going to give the hydrogen gas. So why? Because here they are the strong reducing agent. In case of, instead of hydrogen, nitrogen oxides and water formation, regarding that we are saying that these are the strong oxidizing agents. But when it comes to the magnesium and manganese, these are giving hydrogen gas. Why? Because these two metals are strong reducing agents. This you have to remember. In the very dilute condition, zinc is giving the hydrogen gas, and potassium in very dilute condition giving the NO. So these also you have to remember. So next we have, this is called as, in the first chapter we have displacement reaction. So what is a displacement reaction? Highly reactive metal when reacts with the least reactive metal which is in the aqueous solution form. Displacement occurs. So here ferrous sulfate is formed, which is reddish brown color, and blue color will be fades, turns to pale green. So here color of the solution is blue. So next, generally metals reacts with the acids, we know that. But when it comes to the few metals reacts with the bases also. In that we have the consideration of aluminium, lead, zinc and iron also. Aluminium, zinc, iron, lead. These are the four elements behaves as an amphoteric oxides, means which will reacts with acids as well as the bases. Acids and bases. This will be known as an amphoteric oxides. So when it comes to the zinc and aluminium, we have, regarding the zinc and aluminium in NCERT textbook they given. So here zinc when reacts with the sodium hydroxide, we are getting Na2ZnO2. What is this product called as? Sodium zincate. This product called as sodium zincate. Na2ZnO2, it is called as a sodium zincate. When it comes to the NaAlO2, it is called as a sodium aluminate. Okay, so in both the cases we are usually seeing hydrogen gas liberation. Hydrogen gas is liberated. So now we will go for the next slide. So here earlier we saw the properties now. So once again we will see here. Copper is reddish brown color. So this is a copper, reddish brown color. Silver is in gray color. Gold is a lustrous. And when it comes to the iron, also gray color. And next, these are not there for you. This is the aluminum, dull appearance. So here, next, if we go for the reaction, metals when reacts with the chlorides, we will get the respective salts, metal chlorides. So sodium when reacts with the chlorine, we are getting sodium chloride. And calcium reacting with the chlorine gives the calcium chloride. So when non-metals reacts with the chlorine, we are getting respective acids. So here, when it comes to this hydrochloric acid, phosphorus trichloride, okay, these are generally covalent in nature. So when metals reacts with the hydrogen, we are getting respective hydrides, sodium hydride, calcium hydride, like that we will get. Non-metals when reacts with the sulfur, we will get the respective hydrogen sulfide. When nitrogen reacting with the hydrogen, we are getting the ammonia. So here, this is about the covalent. Non-metals generally used in the involved in the covalent bond formation. And when it comes to the metals, those will involve in the ionic bond formation. When metals and non-metals combine with each other, we are getting the ionic compound. So when these are going to combine, that will be called as a chemical bonding. See here, chemical bond, force of attraction that holds atoms together, that is known as a chemical bonding. See here, sharing of electrons taking place means it is considered as a covalent bond. It will be considered as a covalent bond. When it comes to here, sharing of electrons taking place. Generally, carbon is having 4 valenced electrons. Those will be shared with the chlorine having single electron. So these are going to represented with the Lewis dot structures. Okay. So when it comes to the nucleus is having the attraction forces, that will be shown covalent bond representation in the figure. And next we will go for the next slide. If generally, what are the conditions when we can consider what type of bond is present? So here, whenever two bonded elements are having greater than 1.7 electronegativity, the bond will be known as ionic. And if less than 0.8 is there, sharing of electrons are taking place, then it will be known as a covalent bond. So here, polar covalent, in that case, we have 50% ionic and 50% covalent character. So here, then we have the types of ionic bond. If you see here, generally sodium is having 1 excess electron in the outermost shell. What is the electronic configuration we will write for the sodium? 2, 8, 1. This is the excess electron that's supposed to be lost by the sodium element. So then it will be converted into 2, 8 configurated Na plus ion. Here already we written. So when it comes to the Lewis dot structure, how we supposed to write? 4 sides, 2 electrons and total 8 electrons with the positive charge. Why? Because 1 electron lost by the element. So this electron is going to be captured by the chlorine. So how? When it comes to the chlorine atom, we used to write as 2, 8, 7. It required 1 electron to accept, then it will be converted into Cl minus with the configuration of 2, 8, 8. So here the electron is lost by the sodium element but accepted by the chlorine. So here we can say that by transfer of electrons from cation to the anion, resultant bond formation is known as an ionic bond. So here sodium is losing the electron and chlorine is going to accept the electron. In that way, Na plus and Cl minus is going to make up the bond. Then it will be known as an ionic bond. When come to the covalent compounds, sharing of electrons taking place, clearly here also represented. Sharing of electrons, there is no ion formation. Here ions will be formed. So let me go further. These are the conditions. So these are not necessary for you. So just skip that one. So and one more thing. So when it comes to the impact of the strength of the ionic bond. So generally these are oppositely charged particles involving in the bond. So that's why they have the strong electrostatic force of attractions. This is a very, very important term when it comes to the ionic bond. Generally, these are having the strong electrostatic force of attractions between the oppositely charged particles. That leads to the ionic character significance in the ionic compounds. That leads to the stability of compound also. So now we have the Lewis-Dart structures. So here ions generally, did you see this? Here anion is given. What is the formula we will write as F minus. When it comes to chlorine, Cl minus. Here O minus 2. Here S minus 2. And here N minus 3. Here Na plus. Here K plus. Here Mg plus 2. So whenever we are taking, we are seeing all these compounds. So here the symbol is given, charge is given. That is the only difference. But when it comes to the electrons representation, for each and every element, whether it is a cation or anion, we are simply writing that structure and that symbol, and each side we are keeping two dots. Total overall electrons, 8 electrons completed means we are closing the bracket, and according to the question, whatever the charge giving, that symbol we are representing above the bracket. So Lewis-Dart structures of ions is very easy. So then when it comes to the formation of ionic compounds, here we have to consider the balanced electrons of the each and every element. So here suppose sodium chloride is a compound given means, first of all we have to know that first element always represents the metal part and next half always represents the non-metal. So here we have to write individually those metals. So here sodium separately written and chlorine also separately written. So when it comes to sodium, one valency electron, so that's why we written one valency electron. And when it comes to the chlorine, we have the 7 valenced electrons, those were represented. Each side only 2 dots we supposed to keep. So then one side we have the vacancy for the 1 electron. That electron will be contributed by the sodium. So then ionic format means how we supposed to write? Na with the total 8 electrons, closed bracket, 1 electron lost by the sodium, that's why plus 1 we have to show. Then plus chlorine is going to accept the electron, so that's why once again we have to write the same 8 electron pattern, close the bracket and minus 1 to represent the gained electron. So then Na plus Cl minus giving rise to NaCl. So in that way for KCl also we have to do the same pattern. So when it comes to the magnesium chloride, so here magnesium is having the 2 valence electrons. So that's why 2 dots we have to keep. When it comes to the chlorine, here two vacant electrons were. So one chlorine is having only 1 vacancy, but here 2 excess electrons were there in magnesium. So that's why 2 chlorine atoms we have to take, and 2 fluorine atoms are going to take 1 electron from the magnesium. So that's why here once again we are getting Mg. Ion means total 8 electrons, closed bracket plus above that plus 2 electrons. Here 2 chlorine atoms are going to accept 1 electron. That's why we are representing with a -1. So then each chlorine is taking electrons. So that's why it will be shared and we are representing like this. Then finally we will get MgCl. When it comes to the magnesium oxide, here only 6 electrons were there. So here only oxygen required 2 more electrons that will be contributed by the magnesium. So that's why here 2 electrons directly given by the magnesium and Mg plus 2, and O is going to get total 8 electrons with a -2 charge. So then magnesium oxide formation taking place. Here 2 electrons lost by 1 magnesium atom and 2 electrons accepted by 1 oxygen atom. That's why -2 charge we are giving for the oxygen. To represent 2 electrons accepted from the magnesium. Here magnesium is going to lose 2 electrons. That's why to represent that we are showing with a +2 charge. Okay. In that way when it comes to the sodium oxide. So generally sodium is having only one valence electron. Means here we need to take two sodium ions. So that's why two sodium ions separately represented. When it comes to the oxygen, it is having 6 electrons. It needed 2 more electrons. So that's why those 2 electrons will be contributed by 2 different sodium atoms. Then oxygen is going to get -2 charge. Only one oxygen is accepting 2 electrons, that's why -2 charge. But when it comes to sodiums, only one valence electron. So if 2 sodium atoms are going to give the electrons, then it is going to give the octet configuration. That's why we are keeping 2. Means what is the meaning of 2 here? Means 2 sodium atoms are going to lose 1 electron. So then we are getting Na+1 and O -2. So here why they represented here? 2 sodium atoms are going to share 1 oxygen. So Na2O is formed. These are the 2 more examples you can see and you can try to do it. And now properties. When it comes to the ionic compounds and covalent compounds properties, generally ionic compounds are solid in state. And when it comes to the covalent compounds exist in all the 3 states, and melting points are very high for the ionic compounds, and for covalent compounds these are low, and electrical conductivity is there for the ionic compounds. For covalent compounds no conductivity is there. Water solubility more highly soluble and more soluble. When it comes to the covalent compounds, low soluble. So conductivity when dissolved in water, for ionic compounds it is possible. For covalent compounds it is not possible. Why? What is the reason? Here free ions are available. Ions are available. Free ions are present. Dissociated ions are available. Because of that reason it is showing the conductivity property. But when it comes to here, ions are, electrons are absent. Due to that conductivity property not shown by the covalent compounds. So see here, when we are taking sodium fluoride, generally solid in structure, solid form, closed packed structure, crystalline structure. So here all are closely packed. But when dissolved in water, see here, these are going to dissolve. So this is the, this will be representing water molecule. So here sodium dissociated. This plus symbolizes sodium plus, and this green color represented chloride ion. So these are earlier attached in the compound format, but when dissolved in water, so chloride ion separated and sodium ion separated. So more number of ions, free ions are available, we are saying. What is the meaning is, the compound when dissolved in water dissociated into ions. Because of that reason only conductivity property will be shown by the ionic compounds. See here, positive hydrogens are attracted towards the chlorine ions. So next, negatively charged. So here sodium plus ions are trapped in that. And oxygens are attracted to the cation sodium. So next, when it comes to the covalent compounds, non-polar in nature. So that's why soluble in non-polar solvents like carbon compounds. So here these are having the weak van der Waals force of attractions or intermolecular force of attractions. So that to overcome that, this will dissolve in the non-polar solvents only. Ionic compounds soluble in water. When it comes to the non-polar substances dissolved in water, they can't dissolve. Why? Because these are ions, these are no charged particles. So that's why these will be separated out. Okay, this is about the covalent bond. And when it comes to the polar solute and non-polar solvent, if you take, those are non-ionic part, these are the ions. So that's why these will not be dissolved and comes separately. So in this way, ionic compounds solubility in water soluble in polar solvent. So here we have to say that ionic compounds soluble in water. Covalent compounds insoluble in water. So next important topic is about metallurgy. So here, metallurgy. What is the meaning of metallurgy? Extraction. The study of extraction of metals is known as a metallurgy topic. It is there in engineering as well as in +2 CBSE also there. And meanwhile, now you people also having this. In social studies also it is one of the major chapter. So please listen everyone. Terms, basic terms, everything you're supposed to learn. So here when it comes to the minerals. So generally these are the ores which will be exist in the combined state. So from that we are going to extract the metal. That process, those are known as the minerals. Naturally occurring materials, so which are exist in the combined state, so those will be known as the minerals. So next we have the ores. So generally ores are all considered as the minerals. Those are particularly having the economical importance. Under certain conditions we are going to preferably extract them. So those will be known as the ores. So here one statement we have to remember. All minerals can be considered as ores, but all ores cannot be, all ores can be considered as minerals, but all minerals cannot be considered as ores. So what is the reason? When it comes to the ores, they have the economical importance. But when it comes to the minerals, generally extraction of the metal from the combined state of the substances, that is known as a mineral. So in that aspect, we have to see that all ores will be considered as minerals, but all minerals cannot be considered as ores. Okay. So here we have to say reason is this one, economical importance. Gangue. So the impurities present in the ore which will be used to remove the unwanted substances. Flux is the substance which will be used in the furnaces to smelt in the smelting process to remove the gangue. Slag. So when the substance gangue is mixed with the flux, then it will be known as a slag. And next topic, roasting. It is a very, very important one. Roasting is the, generally we used to see roasted means deep fried. So here we have to take heating of the substances in enough air, means in presence of excess air, then that will be known as a roasting. To remove the volatile impurities, we will use the roasting process. Here, generally roasting is mainly used for the sulfur ores. Next, smelting process. Smelting is melting of the substances. So in that case, removing of the gangue takes place, that is known as a smelting. And calcination will be takes place within the limited air. Then the carbonates will be converted into the respective metal oxides, that is known as a calcination. These are the important terms where we will use what were used in the metallurgy topic. Pyrometallurgy. Pyro means by oxygen, enough oxygen supply, heating of the substances, and then ore can be converted into the metal. That procedure is known as a pyrometallurgy. And hydrometallurgy. Hydro means in the aqueous solution for extraction of metals, then that is known as a hydrometallurgy. Electrometallurgy, it is electrolysis of ores to get the purified metal, that is known as electrometallurgy. These are the few terms we will use in the metallurgy concept. So now, when it comes to the ores, here concentrate. First step is concentrating of ores. This is the first step. When comes to the extraction of metals, first step is concentrating of ores. So here surface impurities will be removed. So here magnetic separation, one of the major things. See here. Here we have continuously movable belt is there. On that the ore is continuously poured from here. See here, from here they are pouring the ore on the movable magnetic belt. So whenever continuously this ore is poured, so here magnetic substances collected near the turbine, and away from the turbines we are getting the non-magnetic substances. In that way surface impurities will be removed from the magnetic separation. Here you have to consider one thing, that either ore or impurities, any one of them must be magnetic in nature. Then only we will use the magnetic separation. So next we will go for the next slide. So hydraulic washing. So hydraulic washing means generally surface impurities removed by forceful pouring of water. So whenever water will be poured in the layers, so here ore will be settled down and impurities will be gradually floats. In that way those will be separated out. Next, froth floating. So here this is a frothing clamp. So in that it is connected with the froth, so which is having the pressure gauge. So agitator is there. In this, in the fine holes we have the pine oil. So whenever pressure applied on the gauge, so here from these holes, fine pores, we used to get the pine oil that is going to combine with the water. So whenever continuously it is going to rotate, applying the pressure, pine oil is released out, and that leads to the agitations, means effective collisions between the ore substances which are present in the water along with the pine oil. So those are opposite in nature. That's why those will hit with each other and collisions will be taking place. So in that case, surface impurities will be, impure substances will be moves away and concentrated dense particles will be settled down. So in that way separation of the impurities from the ore will be taking place. So next leaching is there. So here it is not there for you in NCERT, so that's why I am leaving this. So for in social it is there for you about the bauxite to the aluminum oxide formation. This is very important in the social. So please everybody look after this. Okay. So next we will go for the next one, extraction of the crude metals. So when it comes to the reactivity series based, we have to go for the procedures. When it comes to this potassium, sodium, calcium, magnesium, aluminum, these are the highly reactive metals. That's why preferably we will go for the electrolysis procedure. So here procedure used is electrolysis, or else we can say electrolytic reduction process. So next, when it comes to these metals, comes under moderately reactive metals. So that's why we can able to extract the metal by using the reducing agents like carbon monoxide and aluminum are highly reactive metals. Displacement also advantage. So when it comes to this, so these metals will exist in the either oxide form or in the chlorides, means halides form. Sorry, I will write one second. So these highly reactive metals exist either in the oxide ore form or else halide in the ore form. But when it comes to this, there is a two possibilities. One is a sulfide ore form, another one is a carbonate ore form. Sulfide and carbonate. Sulfide ores, for that we have to use roasting procedure, and carbonates, for this we have to use calcination. So here limited or absence of air. Here excess air will be supplied. Burning of the substances is common. So then when it comes to these are the least reactive in nature. So then by direct heating we can get it. But here one thing is that auto reduction property. What is the meaning of auto reduction? Itself, when exposed to the atmosphere, these metal oxides reduces themselves to the sulfide ores. That is known as auto reduction. To prevent that, we will go for the electrolytic refining process. To get the purified metal, we will go for the electrolytic refining process. Only this is applicable up to the copper. So silver, gold, platinum, these were exist in the free state, and noble metals, these are not going to react with water or other substances. So that's why we can dissolve them in the aqua regia, which is having 3:1 ratio of hydrochloric acid and nitric acid. That is also known as a royal water. Both between the concentrated condition. So now, highly reactive metals, electrolysis. See here, this is anode and this is a cathode. So we are taking, these are the graphite electrodes only. In the aqueous solution form, we are taking molten sodium chloride. So here, not aqueous, molten state means ready to melt. Pure sodium chloride solid only. This is ready to melt, convert into the liquid. In that state, we are taking the sodium chloride in the electrolytic cell. So whenever current is passed through the electrodes, so sodium chloride can be dissociated into Na plus and Cl minus. Na plus ions moves towards the cathode, which is having the negative charge, and anode is having the positive charge. So that's why oppositely charged chlorine will comes towards the anode. So here sodium metal will be deposited on the cathode. So electrons flow taking place from anode to the cathode, and current flow taking place from cathode to the anode. Okay. So porous screen is arranged. Why? Because through the semi-permeable, this porous screen, there is no flow of the oppositely charged electrons towards the oppositely charged electrodes. To avoid that, we are keeping the porous screen. So then, here, what is the reaction we have to write? At cathode, Na plus plus 2 electrons giving rise to Na, and here chlorine minus 2 chloride ions are going to lose 2 electrons and giving gas a chlorine gas. This is at anode reaction. This you are supposed to write. In the electrolytic cell, 2 electrodes, graphite electrodes are dipped, as one is anode and one is a cathode, and which is anode is a positively charged electrode and cathode is a negatively charged electrode. In the electrolytic cell, a molten sodium chloride or fused sodium chloride is taken. So whenever electricity passes through the electrodes, sodium chloride melt and dissociate into ions. Then sodium plus ions moves towards the cathode and chloride ions will move towards the anode. In this way, you have to write along with the equation. So roasting and calcination. Sulfide ores converting into the oxide ores. Okay, in the presence of enough air. So that is known as a roasting. So here one is the example, zinc sulfide converted into sulfur oxide, zinc oxide. And calcination, carbonate ores converted into the carbon oxide, carbon dioxide is released here. In roasting, sulfur dioxide is released. Okay, this you are supposed to remember. So next, reduction by using the reducing agents, displacement reaction. Then here one of the major important equation, that is thermit reaction, you have to remember. Thermit reaction you have to remember. Aluminium powder when reacts with the iron oxide giving rise to aluminium oxide along with the iron. So where it will be used to join the broken railway tracks and spare machinery parts. So this will be the use of thermite reaction. And cinnabar, one more thing is that cinnabar is magnesium sulfide. This one already given. Magnesium sulfide is the cinnabar. This is also cinnabar, mercuric sulfide. by roasting process we can extract the magnesium oxide. Then upon direct heating we will get the mercury. So when it comes to the thermite, already just now I said. Next, auto reduction. Generally lower the activity series, very unreactive in nature, so itself reduces to metal sulfides. To prevent that, we are going for the auto reduction. So copper sulfide is going. Cupric sulfide is going to react with oxygen, gives the copper oxide and sulfur dioxide. And this copper oxide once again react with the sulfur. So that's where cuprous sulfide is formed. So to prevent that, when we are taking both the compounds, copper will be extracted in the purified water. So this is one of the procedure to collect the pure metal. Hydraulic separation, it is not there for you. So liquefaction, it is also not there. Distillation, mercuric distillation also not there. So electrolytic refining process, it is one of the very major important concepts. See here, in the electrolytic cell, we are taking the copper electrodes. So copper anode, which is positively charged one, copper cathode, which is a negative charged one. So here acidified copper sulfate, blue color solution we are taking, and by passing the electricity, so copper sulfate can be dissociated into ions. So here Cu plus and SO4 minus 2 ions will be dissociated. So this Cu plus 2 ions will be moves towards the cathode, which is having the negative charge, and here this copper pure metal will be deposited. So this sulfate ions moves towards the anode. Okay, then those will be left as a anodic mud here, settle down near the bottom of the electrode, near the anode as a anodic mud. So in that way, dissociation of ions will be takes place. And at the cathode, what we supposed to write? Cu plus 2 electrons gives rise to Cu. When it comes to the anode, what we have to write? Cu, just a minute. So here Cu gives rise to Cu plus 2 electrons. These electrons will move from the anode to the cathode. Current will flow from the cathode to the anode. Current, and here electron flow. Anode to cathode. Cathode to anode. So in that way, by using the electrolytic refining process, we are going to extract the purified metal. So next we have the alloys. What is the meaning of alloy? A homogeneous mixture of two or more metal or metal non-metal, that is known as a alloy. So what is the purpose of making alloys? Prevent the corrosion, okay, and give the high durability and sustainability, increase the hardness and increase the resistivity. We are going for making alloys. So brass, bronze, solder, stainless steel, these four are very, very important. Everyone please focus on this. So in the soldering purpose, solder is used. What is the reason? It is having a low melting point. Okay, so this is about the here nickel also there. So now, one more thing. For corrosion, essential conditions are moisture, air, and oxygen. Okay, regarding this, how can we prove that? So in that case, in the 3 test tubes, in your NCERT textbooks, one given the 3 test tubes 3 test tubes. One test tube is filled with the hot water. Another test tube is filled with the cold water. And one more test tube is totally dry. So in this hot water kept iron nail. And this also kept iron nail. And here also in dry test tube also kept iron. So here in the hot water, here they filled oil. Above the hot water, they filled oil. So they closed it with a cork. A rubber cork is kept here. And here also cork is kept. And in one more beaker, test tube, cold water taken, iron nail is placed, above this oil is filled, and it is also closed with the cork. So this one cork will be removed. Okay. So in this case, if you see here, hot water is there, air supply is stopped because of oil. So in that case, what will happen? Here iron nail won't be rusted. Here no rusting takes place. When it comes to here, water supply is there, air, enough oxygen is there, air supply is there. So here we used to see rusting, reddish brown color spots on the iron nail. When it comes to here, there is no chance only. When it comes to here air flow is stopped because of oil. So in that case, here also we won't see the rusting on the iron nail. So from that we can conclude that moisture, air and oxygen supply is essential for the rusting of iron. Okay, this is about the topic better. So thank you everyone. Still if you have any concerns, please later in the next class you can ask me, or else we will see. Okay, thank you children. I'm going to wind up the session. I hope everybody, by seeing this this video, you can get the clarity about the metals and non-metals chapter, and I hope you will write exam very well. Okay, thank you children. I'm going to wind up the session. Thank you everyone.